Hey guys, so we're going to keep going with the SPG review. So this is part 3 and this is the atomic structure. So for this section, you need to get out your beautiful, fabulous, amazing, one-of-a-kind periodic table. Please make sure that you have this because just writing down the answers is not going to be beneficial if you don't know how to read and understand this. So please and thank you. All right. So first off, the top wants you to be able to identify a element on the periodic table. Like just know what even these numbers represent. So the numbers above the element symbol is going to be your atomic number. Now, I know it's asking and talking about carbon, but let's see which one is in the shot. Let's see, calcium. Calcium, which is in group 2, going straight down, second group, has an atomic number of 20 and an element symbol of, see if we can get that real nice and close, an element symbol of Ca with the name underneath, calcium. Now, the next question asks you, what is the bottom number underneath the name? So that's going to be the atomic mass unit, the AMU. So remember that there's things called isotopes in this world, and we'll get more into isotopes later in a little bit. But isotopes, so they take all of the elements in the whole wide world and they estimated. And they took the average mass unit because protons and neutrons together make up your atomic mass. Now, we know because we're smart, brilliant, intelligent chemistry students that if we change the protons, we are going to be changing the atomic number. Remember that every single element has its own atomic number. Hydrogen, 1, helium, 2, and so forth down the periodic table. So if I added another proton to hydrogen, he is no longer hydrogen. He is helium. Helium has 2 protons. The protons give them their identity. And those protons, those atomic numbers at the top, right above the element. So magnesium is 12. So magnesium always has 12 protons. But what makes it an isotope is the fact that if it has too many or a little less neutrons, those neutrons still have an equal weight as protons do. So if he doesn't have the normal, that means he's going to be an isotope. So how they formed the atomic mass was taking the average of everyone's weight, the mass, and they formed that AMU, and that is below. That's why it's a here and there number, like not an absolute of 12, 14, 92. But it's a rounded number of like 12.011 or 14.01 for nitrogen and so forth. So, all right, so number 13, they're asking blank is the smallest particle that still retains the properties of an element. Its identity, what it is. So that is going to be protons. Protons is what identifies your element as carbon, oxygen, hydrogen, nitrogen by its atomic number. Then, number 14, what is the overall charge of a nucleus? Well, think about it. We have inside the center, the inner part of an atom, and I'm going to draw this out because my hand movements are just like, meh. Okay. Oh, Old Navy has a sale on dresses. So, inside an atom, Again, I am not an artist. So inside the middle of an atom, you're going to have the area called a nucleus. It is literally the inside of the atom. But it's home to two things, the neutrons and protons. Both protons and neutrons both have a 1 AMU weight. But neutrons are no charge. Protons have a positive charge. So think about it. If you have something that's neutral and you have things that are positive, what's going to end up being the overall charge? And I'm really hoping you're thinking positive right now. So the nucleus in the center has an overall charge of being positive. Then make my awesome little butterfly. And this is not an absolute drawing. It is just something that to explain it. Then on the outer part of the atom is going to be an electron cloud. And the electrons live there. And we're going to get more into the shells and talking about orbitals and everything like that. So these guys out here are negative. These guys right here are positive. And then these guys right here are no charge. All right, so for an electron, you're going to want that funky E, the really pretty one with a negative sign. For protons, you're going to want the pretty P with the positive sign. Then neutrons are going to have the pretty N with the 0 because they don't have a charge. Now, electrons are located on the outside of an atom known as the electron cloud. It has a negative 1 charge for every electron. And it does have a very, 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 very baby weight, but at this level of chemistry, all you need to know, it has a mass of 0 because it's like 0.00000, tiny little thing. So protons have a positive charge, live in the nucleus, which is the inside innermost of the atom. Then it has a positive charge, it has a relative mass of 1, and neutrons live in the nucleus, they have 0 charge, and they have a relative mass of 1. So the only masses that make up your atomic mass, which we talked about from up here, number 12, is going to be your protons and neutrons. So this little parentheses right here, this simply goes with number 12, not with 11, 12. So, all right. Atoms with the same protons are called isotopes. So, isotopes, but that also means that they're not going to have the same mass, the AMUs, or doesn't have the same number of neutrons, more precise. So isotopes are going to be the exact same substance, but are totally different masses because one may have more or less neutrons. Now remember with isotopes, we use the real world example of identical twins, that they're both made the same, they look alike, they function the same, but if one twin decided to be athletic and one twin just decided to not be healthy and gained a little weight, the second twin has more neutrons and the other one does not. So there is just a difference with them. So remember that the number of electrons in a neutral atom, so something that doesn't have extra charges, so something neutral, has the same number of protons. That is why it doesn't have an extra charge, because your positive and your negative are going to be the same. Now, if I had an ionic atom, that means that it's just going to have a different charge if it's positive or negative. Remember that we talked about cations and anions and everything like that. So we're going to get more into that. But yeah, just if their protons stay the same, it's going to be the same substance. But if their electrons change, the electrons are what defines if there is a extra charge. All right. So number 18. How many protons are in boron? So find boron. Trying to figure out where it is here. And you should see that boron, when you're looking at the periodic table, has an atomic number of 5. So because he has an atomic number of 5, boron has, making sure I'm put it right, boron has 5 protons. So, next question, number 19. What is the atomic mass for potassium? So remember, potassium is going to be K. So, make sure I angle it up right. So, potassium has a 39.10 AMUs. And he has an atomic number of 19. And he has a element symbol of K, and his name is potassium. So remember to please include units. Do not leave numbers naked. So it is 39.10 AMUs. So next question, 20. Ask you, what is the atomic number of magnesium? So you're looking for Mg on the periodic table. And Mg, when we look at him, he is right next to sodium. And magnesium has a 12 atomic number, which means he has 12 protons, and when he is a neutral atom, he's going to also have 12 electrons. Now, he also has an atomic mass of 24.31 AMUs. So, if you wanted to figure out how many neutrons he has, you should be able to take 24.31, subtract 12, giving it to 12.31, round it down. So estimately, he has 12 neutrons as well. Now, not every element on this periodic table is like that. There are some that have more neutrons naturally than protons. It just happens that magnesium has 12, 12, 12. 12 electrons, 12 protons, 12 neutrons, because his AMU is 24. So, number 21. How many neutrons are in the zinc atom? So again, I drew this out here just to help visualize it. So because zinc has an atomic number of 30, which is the number of protons, and he has an atomic mass of 65.409, and zinc is right here. So when you take 65 minus 30, you're going to get 35, which we talked about a second ago in magnesium. Zinc doesn't have the same number of neutrons as he does protons. So zinc atoms have 35 neutrons on average. So 35 neutrons. All right. If an atom has 12 protons, 12 neutrons, and 12 electrons, what is its atomic number? I think that was supposed to be atomic name. So I put magnesium, or the atomic number. So the atomic number automatically is 12 plus 12, which is 24, which is AMU, which magnesium has a 24.31 AMU, so that's pretty close. So 12 plus 12 is 24. So for number 22, the atomic number, technically that's the protons, is 12. The atomic mass is 24. The name, magnesium. All right, with 23, and we're right down here. If the number of protons change anytime, and we talked about this in radioactive elements, anytime you change the protons, you change the element to something else, period. He becomes something new. So if the number of protons change, then the element changes. So, all right, that concludes part 3 of the atomic structure. Again, please message me, let me know if you have any questions, and I hope this was helpful. Come find me if you need additional time or tutoring. Have a good night, and please do not wait to study till the last minute.